Alright. Here we go. Geometry, chapter 10.5. We're talking about tangents. So, a tangent is a line in the same plane as a circle that intersects the circle in exactly one point. Means it only touches it right there. Now, sometimes the way we draw it for the thickness of the line, it looks like it touches more. But it touches in one point. It's called the point of tangency. A common tangent is between two circles. It's a tangent that two circles have in common. And remember, these are all in the same plane. Okay, so here we have a problem. It says, copy the figure, draw the common tangents. If none exist, then say no common tangent. Okay, between these two circles, we have a common tangent here and a common tangent there. So two common tangents. Between these two, we have this tangent and these two common tangents, kind of like the last example. However, these two circles also have this tangent and the opposite one. Okay, so when they're not touching, they have four common tangents. Theorem 10.10 says that a line is tangent to a circle if and only if it is perpendicular to the radius. Okay, perpendicular to the radius from the center to the point of tangency. Alright, here we have a problem using this. So it says that JL is the radius. We need to determine whether KL is tangent to the circle. Okay, so remember, if it is tangent, then it would be at a right angle to the radius. So that's what we're going to have to look for. Determine whether this is a right angle. And in order to figure that out, I'm going to make sure that this is a right triangle. Okay, so this section right here is 9 to the circle. So I need to figure out what length this is. Well, we know that this is 8 right here. A squared plus B squared equals C squared. So figure out this is 8 because that's also the radius. Okay, and now we want to see that this A squared plus B squared equals C, and C is 9 plus 8 squared. So we got 64 plus 225 is 289. And those do equal. So this is a right triangle, which means this is a right angle. And so KL is tangent to the circle. Alright, now this time we know that JH is tangent to the circle at J, and we want to find the value of X. That means we know that this is a right angle, so we know that this is a right triangle, so we're going to use the Pythagorean theorem to figure this out. That means short side, GJ squared, JH squared is equal to the long side, the hypotenuse, at GH squared. And now this is X plus 12 squared, and this side is X plus 8 squared. Once I square that, I get a trinomial over here, and I can cancel out the X squared, subtract X squared from each side. I get 144 is 16X plus 64. Subtract 64 and divide by 16. So X is 5, and that's what we were looking for. Okay, Theorem 10.11. Tangent lines through an external point. Okay, so we have a point here. From that point, if two segments from the same exterior point are tangent, then these two are congruent. Alright, so if I want to use this, here we know that these lines are tangent to the circle D. So find the value of X. So we know that this is congruent to this, which means X plus 15 is equal to 2X minus 5. So solve that, and we get X equals 20. That's all there is to this. like and subscribe.